This is my Elliott Victoria milling machine. It's a horizontal milling machine with an optional vertical head, and this is the vertical head. It's very versatile. It can rotate that direction, and the head can also rotate in that direction. It's actually the first time I've used this vertical head, and I don't have a drawbar to hold the tooling. It has a number 2 Morse taper socket, so I could just simply use a bit of threaded bar put a nut on, and that would hold the tooling in place. The problem with that is when you want to release it, you have to hit it with a hammer, which is not too good for the bearings, obviously. So what we need to do is we need what is called a captive drawbar, and we need to make one. I've done a quick sketch to get some dimensions for the drawbar. So the orange outline represents the milling machine spindle. The green outline represents the tool holder. So I've drawn in a drawbar, which consists of 3 components: the drawbar itself, a threaded on round nut, and a taper pin which keeps these in position. There's a hex on the end of the drawbar for tightening and slackening, and there's also a collar on the drawbar which facilitates removing the tool holder. So the general principle of how it would operate is that to fit the tool holder, you insert the tool holder and thread it into the drawbar and tighten the drawbar, and that would put tension in the drawbar and pull the tapers together. Then to slacken, you would loosen the drawbar. As you slacken, this collar would butt up against the inside of the machine spindle shoulder here, and thus produce an axial force separating the tapers. Now the maximum hex size I could get on the end was 7mm, so that's quite small. I would have made this just from mild steel, but as this is quite small, I've decided I would use high tensile steel. So the high tensile steel I'm going to use is an old threaded stud bolt with a yield stress of something like 725 megapascals, which correlates to about 105,000 pounds per square inch. So it's strong, quite tough material. So let's get machining. The final task on this side is to add a 3/8 UNF thread, 3/4 inches long. I've put a black mark on the final depth required. I'm using a circular die. This particular die holder has a floating head. When you fit the die into the die holder and clamp down the adjusting screws, you've got no guarantee that the actual thread of the die is perfectly axially aligned with the workpiece. But by making the head float, then the die will automatically line up with the workpiece. So I'll put some lubricant on. Bring the die head up. I just do this on power. I support the rotation of the die just with this bolt I've screwed into here. To put the 3/8 BSW thread on, I'm just going to use a standard die stock. I'll use the face of the drill chuck to keep it square. I'll put the earth in back here. Some lubricant. It's quite a coarse thread, so it takes a bit of effort. I have the drilling machine, and I have the drawbar and the nut, and it just remains to put these together and drill and ream for a taper pin. So I've made a spacer tube, which will set the distance and also allow me to tighten the nut to take up any backlash in the thread. So I'll just go and tighten that up really tight. I'm going to use this drilling fixture and clamp the small end of this drawbar in the V. Should hold it securely. I'm going to use a spotting drill to mark a position for the drill. And I need to just eyeball in this axis just to get somewhere in the centre. That looks about right. And I'm just going to place a parallel in place, clamp it down, and that gives me a datum to move it in that axis to find the position of the centre of the bar to drill. So I'm just going to use a ruler and place it on, and that gives me an indication of where, if it's in the centre. So if I move off centre, obviously you can see if I move around. So by looking at how level the ruler is, you can determine roughly how close to the centre you are. So I just try and position it so that the ruler is parallel with the table. Just by eyeball. That looks pretty good actually. So I clamp that in position. Just check everything looks okay. Okay, so I'm going to support this end. This is overhanging, so if I put pressure on here it could move. So I'm going to just use this adjustable parallel, which I've already adjusted, to fit under there to provide a little bit of support. And we're ready to mark the position. Okay, the small end of the taper pin is 2.7, so I'm drilling a 2.7 hole. And we put some lubricant on. So this is high tensile steel, so it's quite tough. So we need to take our time. Okay, we're ready for the reamer. This is the taper pin and this is the taper pin reamer. So we just need to ream this hole so that the taper pin fits okay. Now you have to be very careful because with this reamer you're cutting the full length. Once you get the reamer through to the proper depth, you're cutting the full length of the flute. And this is quite fragile, so we need to be very, very careful. I'll probably finish it by hand, but we'll get it started on the machine. Give it plenty of lubricant. And we want to go really slow. It is cutting. Yeah, it's through to the power there. So I'm just taking little bites. It's difficult to get the sensitivity with a small tool like this. So we'll try the pin there and see what it looks like. Okay, so there's a fair way to go. I can feel when it's just taking a little bite. I don't want to push it too hard. I can feel it's getting a bit more difficult, a bit more force required. Try the pin now. Still a long way to go. Okay, I'm going to finish up by hand. So I'm continuing by hand. And this gives me a much better feel of what's happening to the reamer as it cuts. How difficult, how hard it is for those flutes to cut that material. It's going quite well. Let's give that a clean. Try the pin. It's going in. Okay, we'll try the pin there. Okay, that will do. Clean the reamer. So we're at the decal mill now, and I've got my cheap Chinese indexing head clamped onto the table. This gives me 1 degree divisions, and it uses an 5C collet. So I've got a 3/8 collet, which is 9.5mm. So I'll just fit this in here. Find the keyway. There we go. Position about there. Okay, so I'm going to set it to 0 position. Lock it down. So we need 7mm flats on here, and this is 8 diameter, so it's 0.5 mm per side. Initially I'll take a 0.3 cut and put 2 flats on 180 degrees apart, take a measurement, and then get my correct depth, and then machine all 6 flats. So we're at the milling machine. I'm just going to apply a little bit of anti-seize compound on that face there. Okay, we just need to find the correct orientation for the pin. There we are. Give that a tap in. Job done. Let's try it with a cutter holder. Unload here. And loosen. Okay, sorted.